Hi. Yes. So, welcome everybody to this installment of Inquiry Labs Academy. It is my great pleasure to introduce Dimitris Kolovos from the University of York. He will be giving a talk about model-based engineering in industry and academic Toolsmith perspective. The floor is yours.
Thank you very much. I'm a visitor, appears. Right, so thank you everyone, and welcome to this talk. As Ako said, my name is Dimitris Kolovos. I'm an associate professor at the University of York. And before I start, I would like to thank you all for coming, but also thank Aktos and Istvan and Daniel for inviting me and for arranging for good weather. It's really appreciated. In this talk, I would like to reflect on my perception of the use of model-based engineering in industry. Obviously, you guys work for a company, you get to meet industrial partners much more often than I do. So what I have might be a partial view, but one of the main reasons why I was interested in having this talk in such an environment is kind of complement my understanding based on what you see every day in your business. And it's a real pleasure to be here at Inquiry Labs, a company that has emerged straight out of the academic world, straight out of research, and that is still delivering some of the most innovative tools in the field of model-based engineering. So, beyond my academic position, I have also been an Eclipse committer since 2006. I have been leading the development of an open source project called Epsilon, which provides languages and tools for model-based engineering. Language is not unlike your own, like Piatra, for example. So I will now briefly introduce Epsilon, as in most cases our collaboration with industry somehow revolves around it. However, this is not meant to be an Epsilon talk, so after a few slides I will get back on track. So Epsilon is a family of languages for model-based engineering. It consists of languages for activities such as model validation, model transformation, model text transformation, but also some more exotic activities like model comparison and merging and pattern matching, etc. The main premise of Epsilon has two selling points, so to speak. The first one is that the languages that it consists of are interoperable by construction because they are based on the same core expression language. So in this case, it's possible to write code once and then reuse it in model-to-text transformations, constraints, model-to-model transformations, and so on and so forth. And the other distinguishing feature is that it boasts a wide range of supported technologies. So it's not bound to EMF, it's not bound to a particular model management architectural technology. It can be used to manage models as diverse as Simulink, structured documents like spreadsheets, XML, and so on and so forth. And what happens is that such models, such artifacts, can be managed in the context of the same program. And I will show a few very brief examples. Epsilon is developed under Eclipse, it's an official Eclipse Foundation project since 2006. So it's fair to say that it's pretty stable. It has stabilized a lot over the years. So from an architectural point of view, this is how Epsilon looks. There are three distinct parts here. So the core of Epsilon is an object language, so a scripting language, object-oriented, with support for lambdas, and so on and so forth, which sits on top an abstraction layer, which we call the Epsilon model connectivity layer, and which provides a minimal set of interfaces for connecting to diverse types of modeling technologies. And then we have several what we call drivers, which implement these interfaces and then allow Epsilon to hook into all of these different technologies such as EMF, which was our main and our first driver. Then we extended to things like XML, more recently to spreadsheets, Simulink, proprietary UML modeling tools, but even things like JDT and CDT, which allow us to do all of these nice things, validation, transformation, and so on and so forth, directly on code. Right? So we can extract views from code, we can make changes to code, and so on and so forth. And then, of course, at the top layer over here are task-specific languages, which are essentially to 90% the core language plus syntactic sugar to define rules, constraints, and so on and so forth. So one of the distinguishing features of Epsilon is that all these different types of models can live in a common space, so to speak. So Epsilon can act as a model integration technology. For instance, here I have an example of a small transformation that transforms models from a proprietary modeling tool called Integrity Modeler to Eclipse UML models. This is only a rule that transforms packages. But if I did not tell you that, if I have not told you that we're talking about these two specific tools, there's nothing in the specification of the transformation that hints this is Eclipse, this is non-Eclipse. It could be anything. And this capability comes straight out of this abstraction layer which hides the underlying technology. So in this case, we have a model called UML, which is an Eclipse UML model, and IM model, which is an integrity modeler. Actually, in order to access this model, we have to go through a Java COM interface, etc. But the developer of the transformation doesn't need to care about any of that. They can treat the models as if they were coming from the same technical space. For another simplified example, we've been looking recently at the interplay between languages such as UML and Simulink, because this is a very popular combination of languages in an industrial context, as we've found. So here, for example, what we want is we want to cross-check a UML model and the Simulink model and make sure that for every activity in our UML model, there is a block, there is a Simulink block with the same name in the Simulink model. So again, here we have two models. We have a UML model, a Simulink model, and then we can write a constraint stating exactly this. We don't have to care about the technical implementation, how we actually go to Simulink, how we get all these blocks, etc. This is implemented by the respective driver. The final example, there's certain, so what I have here is a small model to text transformation that actually generates a class with a lookup function. And the lookup is essentially a switch with keys and values. So if the value is A, the output is B. If the value is B, the value is C, etc. But all of this information is stored, say, in an Excel spreadsheet, in a lookup table, which lives in an Excel spreadsheet. And this is something that you would normally do, for example, in a configuration file. But there are certain classes of safety critical systems where file I/O is not an option. So everything needs to exist, all the information needs to exist in the program. So you would compile a lookup table as a regular class. Okay, so this is just to highlight again the core point, because this will come up again in the rest of my talk. The issue of heterogeneity, of heterogeneous modeling environment, and how Epsilon goes about addressing this challenge. So enough about Epsilon. Let's go back to my insights of the use of model-based technologies in industry. Most of my insights have been acquired through one of the following ways. Either through knowledge partner transfers partnerships, so knowledge transfer partnerships, which are special kinds of projects in the UK funded by a body called Innovate UK, where essentially they pair an academic partner, a research partner, with an industry partner to solve a particular problem, to do technology transfer and solve a particular problem for the company. Then we are involved a lot in big collaborative projects, both at the European level, where we get to work with companies across Europe, but also at the national level. And we are currently involved in a large national project with companies such as Rolls-Royce and British Aerospace and Altron Praxis on reducing the cost of software in the aerospace sector. And much of the work, much of the ambition, it revolves around model-based engineering. So using model-based engineering to actually achieve this. It appears that the aerospace sector, particularly in the UK, is very serious about this, because this is a project that they co-fund. So they put in 50% of the money, and it's quite a big project. And we observe a very high level of involvement, which is very encouraging, I think, for the entire field. And finally, through our involvement in the Epsilon project, some of the messages that get posted to a forum lead on to further collaborations, right? Or private conversations offline, where users explain how they're using Epsilon and what kind of problems they are facing and how they solve them. So these are the three main sources of my experience in with working with industry. So having explained the vehicles through which I collaborate with industry, I thought it'd be useful to list a few common collaboration scenarios in order to provide more context. So what kind of people are we talking with? What do they want out of? What do they aspire? So the first, and perhaps what I would call the more lightweight users of model-based engineering, are high-level people mostly concerned with things like requirements management and risk management and safety management, especially in safety-critical industries. And currently, for most of them, the current state of practice is Excel spreadsheets and Word documents and emails, so little version control. This is not considered to be like a proper engineering activity in some contexts. It's all high-level management stuff. So they're not used to things like version control systems and so on and so forth. You just get loads of emails, Excel spreadsheets called _final 34 something. Our observation is that what this category of adopters are after is really ready to use model-based solutions. So they need ready to use requirements management tools, safety management tools, risk management tools, and so on and so forth. And usually what they're after in terms of capabilities beyond drawing and organizing information is traceability across all of these different artifacts, and also document generation, as well as version control and collaboration, so that they don't have to manage this long stream of emails. So these are the more lightweight users, so to speak, not so demanding users. Then another common category of users are engineers who are deeply involved in software development activities. For some reason, they have to work with a particular set of technologies because of legacy reasons, because the product line of the company is built on these technologies. And then at some point, they identify a particular task in the software lifecycle, which cannot be automated using the abstractions provided by the set of technologies they currently use. So they need some way to typically generate code, right? For example, that goes to 3 different tools, but which conceptually has a single source. So our experience with these engineers is that they are really after robust frameworks for developing DSLs, as well as guidance, right? I have a slide about this later on. And then from all these big model-based engineering toolkit that, for example, the Eclipse modeling project offers, they're usually after just a couple of things, being able to generate code from whatever models they capture, and before they do that, to run some constraints to make sure that the generator doesn't break in random places. And finally, and perhaps most interesting for us, the last group of industries we talked to is organizations who are already practicing model-based engineering for sometimes for many years. They are already convinced about the benefits of model-based engineering, and they are actually either looking to expand the scope of model-based engineering from low-level design and implementation up to more requirements and high-level design-oriented activities, or are looking to maybe change some of their older and proprietary modeling technologies with open source alternatives, or they have a specific performance or scalability problems, like we have a code generator which we wrote when our models were quite small, and then as our models now have reached several hundreds of megabytes, that thing takes hours to run. So come and help us, come and do something about it. So what kind of tools do we encounter? I briefly explained what kind of users we normally see, what kind of potential adopters or existing adopters we see. But what kind of tools do the more mature users, do those that actually engage already in some way with model-based engineering activities? We see a lot of commercial UML tools. Things like Magic Draw and Artisans, then they can see some of you smiling when I say Magic Draw. Things like Artisan Studio, Enterprise Architect, and so on and so forth. So lots of that. Then Simulink, wherever there's some control system is being developed, Simulink is almost guaranteed to be found somewhere there. Spreadsheets, of course, so it's a ubiquitous tool for exposing information, say, to non-technical users, or even for sometimes not having to get a huge number of licenses. So you can, if your engineers only need to see a very small part of the systems, that does not really justify having a full license for the modeling tool you're using, then you may as well export some of the information in a spreadsheet and save some of the licensing cost. Then things like XML and JSON, these are usually not exposed to the to modelers. These are usually used as internal formats so that complex logic does not have to be written in whatever scripting language each tool supports. So say, for example, if you want to do some complex processing on information from a Simulink model, instead of writing this complex analysis in, say, MScript, we found that it's common for engineers to extract an XML document with the information they need to do this analysis, and then use Python or C# or whatever they're more comfortable with to actually write the analysis logic. Code embedded in models. This is standard because at some point you hit the limit of the structural modeling language. Say, for example, UML. You define your classes, you define your operations. At some point, you need to define what they do. Having code in there is quite common. And then we see lots of scripts, right? So, and these are usually in either whatever language is supported natively by the modeling tool, or, as I said, after exporting to some intermediate format, lots of Python, usually scripting languages. And these scripts are not not negligible, right? Essentially, most of them are either what we would call model validation constraints or model-to-model transformations. They can be of the order of thousands of lines of a very complex code that is not only concerned about doing an abstract syntax mapping, but sometimes they're looking into positioning of elements on diagrams, right? Although they are supposed not to carry any information, any semantic information, or doing things like even parsing of code that is placed inside models, things like tokenization and regular expressions and so on and so forth. So when you see this idea of the transformations expressed as here's the left-hand side, here's the right-hand side, and we just delete the link or we delete the token, yes, doesn't really work like that. Okay, so what do you think is missing from this list? Can you spot anything that's missing?
Doors.
I think it falls under, well, okay, maybe not UML modeling tools, but commercial modeling or such tools.
Anything that's web related.
Yes, this is true. Although there is a trend, at least I've seen it in a couple of places already, for people to try to work around the thick clients that modeling or requirement management tools come with, which are usually like they were designed in the 80s, and they were designed in the 80s, most of them. They're trying to replace them with internal web applications that make use of the API provided by the tool to provide the more streamlined experience and perhaps integrate between tools. This is another thing that I forgot to mention, peer-to-peer bridges, because you have all these tools, they all have scripting APIs. They're used in the context of the same process, so there's a lot of code that has been written to send stuff from Simulink to whatever modeling tool and from that to Excel and back and forth. And these are peer-to-peer, and they tend to be quite fragile as tools evolve, which means that as a side effect, you can find very old versions of tools, right? Because when you entangle everything together using peer-to-peer connections, then it's really hard to take something offline and replace it with a new version. And of course, the problem gets worse the more versions you stay behind. So old tools is again something we have encountered.
Open source tools are missing.
Yes, this is true. Anything related to Eclipse, right? Anything related to the Eclipse modeling ecosystem. With the exception, of course, of a few companies who are involved in either really invested in Eclipse technology, so they have internal RCP workbenches and so on and so forth, or they even participate or lead Eclipse project. So we almost never encounter the use of Eclipse modeling technologies. And of course, this is a contradiction because the majority of research presented same conferences like models and stuff, maybe 70 or 80%, if not more. It revolves around the EMF and related technologies. So let's have a look at the big picture of the ecosystem. And I will try to perhaps pick out some of these reasons, some of the, because we ask people, right, what about EMF? Don't you use EMF? EMF is great. Why not? Okay, so I think this is a simplified picture of the Eclipse ecosystem. We start with the Eclipse modeling framework in the middle, technologies for defining concrete syntaxes, textual syntaxes, graphical syntaxes. Then we have at least 2 or 3 different model repository solutions. These are not necessarily projects hosted under the Eclipse Foundation, but these are projects that build around EMF. Then on this side we have Papyrus, and I have a few slides specifically for Papyrus. I think it's a really important component of the ecosystem. And then on this side we have lots of different languages for things like validation and model-to-text transformation and model-to-model transformation. And this is how I will treat them in 3 groups: domain-specific languages, Papyrus, and all of these languages in one bite. Okay, so before I get into the specific components of the ecosystem, let me just transfer some of the high-level concerns that I get when I try to introduce some of these technologies. So the first of all is this is a very large and confusing set of technologies, right? You have overlap between technologies. You have 2 graphical frameworks, 4 model-to-model transformation languages, 3 different model repositories, etc. And to the eyes of an outsider, it's not completely clear why. Do they all do the same thing? If yes, where are the articles that explain which one of them does it better, which one performs better, which one is better for my scenario? There are a lot of tools out there and a lot of frameworks, but hardly any end-to-end solutions. So from a user's point of view, users are presented with a sea of tools, but no processes and no end-to-end examples. Right? For example, for a user that's interested in getting into, say, graphical modeling, they need to develop a graphical DSL. First thing, there's no complete guide that would take them from defining the abstract syntax, defining the editor, writing a generator, packaging and distributing the whole thing up. Right? They have to kind of figure it out for themselves, pretty much, which is in stark contrast with the way that people are used to working with commercial tools, which usually provide this kind of documentation. If at any point you disagree, you want to stop and ask, perhaps ask a question, just feel free. I should have said from the start. Yes.
You are either very brave or you have done it on purpose, that you have left out our technologies from your little map.
Have I? Have I removed pattern matching?
Yeah.
Yes, you're right. Yeah. Sorry about that.
It's very brave. I think this one remark that I think that you are largely right, but this is slowly changing. So,
of course.
So with the the appearance of things like Papyrus that you mentioned yourself, or Sirius, or Capella, I think that the community is trying to slowly but move in this direction.
Yes.
So, but it's probably much slower than what it should be. So
yes.
I agree.
Yes, and I think things are changing. And when I get to the part where I talk about Papyrus, I will talk about that, because instead of having to, as we did in the past, to push modeling technology down the throat of users, now we get people who are interested, starting from Papyrus usually as a starting point, and come to us and ask for help with things like code generation and so on and so forth. So yes, I agree that this is changing. Limited and out-of-date documentation, that's a very common concern. Another issue is that there is a perception that the modeling community is very small, right? And when I try to extract some more information, usually I get, if you go on Stack Overflow and you search for, I don't know, what's your tool, Epsilon, there's nothing. There are very few questions. I think that Stack Overflow is progressively used as a Google for programmers, so people will not even search in Google to get to Stack Overflow. They will just go straight to Stack Overflow. And the Eclipse Foundation has its own forum structure. So a lot of information, lots of messages about Eclipse projects are in Eclipse forums, which detracts from the number of messages in places like Stack Overflow.
I think that a more general statement regarding this, if we are already very is to say that the IT infrastructure of the Eclipse Foundation in general is very lacking and very outdated nowadays. So the forum that you mentioned looks antique to things like Stack Overflow.
Yes.
That might also be a deterrent because it's much harder to find what you're looking for on that compared to what's the state of the art.
Yes, yes, this is true. And I think there are some discussions, at least in the Bugzilla, about potentially moving to a more modern infrastructure. But then there is the issue, I guess, that an open source foundation cannot live on third-party services that may disappear tomorrow. Or
this is
it's a complex.
why there is always this debate between moving the whole thing to GitHub, which at one point they seriously considered, and then abandoned, and now I think it's again somehow on.
I think there needs to be some middle ground somewhere, because I also understand the point that a big open source foundation cannot really have single point of failure dependencies on third-party services, essentially commercial services. And then I get, yes, okay, let's give EMF a try. I have my data in a spreadsheet. I have it in whatever model, in IBM Rational model or in Enterprise Architect model. How can we bring them into that EMF of yours and start working? And then, yes, we have to write a transformation and we have to build an adapter, etc. And people are not willing to do that before they can see any value. So lack of out-of-the-box bridges with what people out there are actually using is also a very common concern. I will quickly jump over this slide and does it annoys Abel? It's the same slide as before. And I will say a few words about the domain-specific modeling facilities within the ecosystem, namely XText and Sirius. They have been doing very well over the last few years. They have made a lot of progress. I think XText is already established as a very mature technology that has unique selling points. Sirius is kind of getting there, and I think this will help lift the community. Now, what I've said so far relates to the quality of these tools, the capabilities, but there's a more fundamental issue that I think keeps coming up when we talk to people in industry about domain-specific languages. And this has to do with, do I want to build a domain-specific language in the first place? Because it might be easy to construct, and it might be really easy these days to get good quality tools on top of that. But tutorials and the like will get you to 80% usually. Then you need a lot of expertise to actually configure them and turn them into an actual product. And this expertise is quite rare. And this goes back to the documentation problem and to the perception about the community and so on and so forth. But also training. So when you define a new language, you need to train your people. You don't just throw them on a tool and hope for the best, right? You need to write manuals, you need to give insight to organize internal training events, and so on and so forth. And this is not even something that you can outsource because it's your language, your tools, no external consultant, no, and you have to organize this internally. Deployment, so getting, compiling, building all the infrastructure that will turn source code into binaries, running your own continuous integration server with Maven and Ivy and God knows what else, is not very appealing as well. And I think this all boils down, or it is projected in the heads of people across 10 or 15 years, because sometimes that's the lifespan of bespoke internal tools, and the DSL is a bespoke internal tool that will have to be maintained for the next 10, 15 years, or even more. So I think while the technologies are getting better, there is, and I think that there will always be this fundamental disagreement with the concept of developing a language that only I use, that only our company uses, which I think is why initiatives like Papyrus are very important. So you need something that works outside of out of the box, right? You need something that implements standards that people can start modeling with without needing to devise their own language, and then have a gradual way of moving, say, through profiles to a more domain-specific solution until you reach the point where you say, right, my domain abstractions are now so much different to UML that I'm better off going with a custom DSL. I think it's a more progressive, that's a more manageable way of going from no modeling to domain-specific modeling. So some good things about Papyrus, some good feedback we've been getting from industry adopters or people who are considering to adopt Papyrus is that it's extensible, because one of the things that they often get beaten by with commercial tools is that they are not extensible enough. There are either some parts of the tool are not exposed through the API at all, or the API is not well designed for extensibility. On the other hand, with Papyrus, everything is extensible, right? It's an Eclipse set of Eclipse plugins. You can stick in a new view. You can listen to selection events. You can do pretty much everything. And there's also plugin development is well understood. Also, it implements standards, so UML and SysML standards, and this is important because when you write transformations, code generators, and so on and so forth, you don't want them to be dependent on usually a specific version of a specific tool, right? Standards are very useful in that regard. So even if you then move to another tool, if it follows the same standard, even naming things, then the cost of the transition is much lower. And I think we've had several companies have been beaten again and again from these custom meta models, custom implementation, etc.
I tend to disagree on this, to be honest, because I think that in theory it can work, like you say, but I think one of the major and well-documented failures of UML has been that this promise, it never really lived up to this promise, because usually if you implement, say, a code generator against UML, you typically implement a code generator against Papyrus UML or Enterprise Architect UML or Rational Software Architect UML.
So Papyrus UML is a standard. I mean UML because it's based on the UML 2 project.
Yeah. But so is there any other UML tool which is 100% compatible with the UML as it is implemented in a standard way inside Papyrus?
No.
So you can't really move from, let's say, in a straightforward way between, let's say, Rational and Papyrus. So once you move to Papyrus, then you are on Papyrus. Of course, it's a standard implementation, but as far as I know, there is no other tool.
I agree. I'm just saying that
which has the same
if you have to select between a number of non-standard implementations of the UML meta model, but there's also a standard implementation of the UML meta model and the tool that supports it, then that tool has an advantage in the sense that it follows the standard, and that if we suppose that in the long run tools will try to follow the standard, just because people move to Papyrus because it follows the standard, and it has a positive effect. So if you have to select between all these non-standard implementations and the standard one, I think the standard has a little bit more value.
I think that it's more realistic to say that rather than just being the standard, I think that the major advantage of Papyrus in this regard is that it's an open community and an ecosystem. So you don't really have a dependency to one particular vendor, but an implementation that at least, let's say, 2, 3, 4 organizations are already proficient with.
Yes, yes, this is another thing. But the fact that Papyrus implements these standards has been mentioned a few times. I don't know if that's because maybe some organizations are used to working with standards, or they have specific standards even for model-based development.
Or it just looks better on paper, that you can show to the management that it's a standard compliant.
Or to the certifications, or they're trying to build an argument that we're trying to follow as many standards as possible.
I think, especially from certification perspective, UML is, I think, still problematic, in the sense that I'm not really aware of any code generators from UML that would be certified so that their output could be used as is.
Yeah. No, but I'm not talking about certifying the artifact, but also certifying the process. So you have to show how you go from your high-level requirements down to the code.
What I want to stress here is that when going to, when I talk to representatives who are using such models, they are normally in these domains like avionics, space, and the like. So big companies with big projects. I think code generation itself was not the first three, not in the first three use cases in that case. So they were using it more in a systems engineering perspective, and not that much for.
Yes, I agree. There are different uses in even different things within the same company, depending on the level of tool automation, on even on the facilities provided by the tool that people are using. So when they see a capability, say when they see a generator that produces code that is close to what they want, they kind of get. It's easier to follow this path.
And it's more likely to be related to the Simulink family than the UML family.
Yeah, but of course, Simulink is really more not generating code from Simulink is at home. Let's put it like this. So, as I said, some of the modeling tools, some of the commercial modeling tools hide part of the information they store. So, for example, it's very hard to get out layout information about diagrams, position of things on the diagram, bend points, and so on and so forth. In Papyrus, everything is stored in XMI. The fact that the models are stored in XMI and they can be split over many files, again, this appears to be very appealing. Because again, existing modeling tools somehow, in order to get collaborative modeling capabilities, they implement their own version control system or their own locking system, and so on and so forth. And the prospect of having one version control system, one set of credentials, being able to push models and code side by side, this seems to be very appealing. And then the open ecosystem of tools on top of Papyrus, because currently for most commercial UML modeling tools, you are pretty much limited to whatever template language or scripting language the tool provides. Right? If you want to use something else, then you need to export to XMI, and of course for big models this is not practical. So you just end up using whatever the tool provides by default. With Papyrus, I think there's a lot more option, and this is recognized. Of course, Papyrus is not perfect, at least not yet. Usability suffers when compared to commercial modeling tools. Sometimes you open a diagram, you edit it, you need to close the editor, perhaps close Eclipse a couple of times until you get your diagram as you like it, because Papyrus may just crash in the middle or may just make Eclipse go unresponsive, etc. But things are much better than they were 2 or 3 years ago. So all this effort that the contributors are putting in is actually paying off. And I'm actually very optimistic about the future. assuming that the companies don't just decide to pull the plug on the project. And then another concern when talking to people who already have a legacy of big models is how does this thing scale, right? XMI documents or files or XML-based. XML doesn't have the best reputation in terms of performance, etc. Yes, you can split models into smaller components, but will at some point profiles go crazy and need to traverse the whole graph of components. There are no large-scale case studies out there saying we're using Papyrus with 10 gigabyte models. I don't know if you guys
not even close to that range.
Yeah. Yes.
And I think that this is an issue which is not even perceived properly within the developer community of the tool. So they are aware of certain issues, but they don't really have any, let's say, infrastructure in place for actually dealing with these kind of issues. And one of the things that we collaborated on with them concerned this area in particular, but it's just the beginnings. So a lot of work needs to be done, I think, in this regard.
I think at some point in one of the Papyrus meetings, it was mentioned that one of the ambitions of the project was to get some sort of an indexing system for model fragments, essentially.
I mean, one technical problem, which is actually comes from the standard itself, is the extensive use of stereotypes, which kind of immediately doubles the number of model elements when you use them.
Yeah.
At the very first stage, and it's embedded in the standard and not in the tool.
Yes. But there are tools, and we have also worked on a tool for model indexing in the context of Mondo. So I think if we get to the point where these are the problems of Papyrus, I think we're in a very good direction. If we start talking about how can it handle very, very big UML models, etc., all the small usability problems, etc., have been sorted out. Right. So now let's go to the third part of this diagram. We talked about domain-specific languages. We talked about Papyrus. Now let's talk about these model processing or model management languages, the transformation languages, the validation languages, etc., as a whole. And most of these tools kind of depend on the use of EMF-based modeling tools because they are bound to EMF. They have strong dependencies on EMF and require a significant learning curve. They're not built on top of JavaScript. They're not like Java annotations. They're brand new languages. So they need someone needs to put in the effort. And none of these is actually a showstopper, but in its own right. But as I said, EMF tools are very rare in practice. When you walk into an industrial collaborator, it's very unlikely that you will find any UML tools there. And also, most of the languages available today, in my view, they kind of lack the killer feature that would justify the trouble of learning them, right? And I say most because obviously there are languages like, for example, Inquiry, which provides support for incrementality, which is something that is very hard to get within procedural or imperative language. But for example, say if we think about model-to-text transformation languages, what is the novelty there compared to things like, I don't know, Velocity and Free Market from 15 years ago? Very little. Okay. So, what can we do about these two issues in terms of dependence to EMF? We can wait until EMF-based tools, starting with Papyrus, kind of take off and lift the whole ecosystem with them, or seriously start thinking about supporting non-EMF based models. And when I say support non-EMF based models, I don't mean export to EMF, because in case of large models, this can be a performance bottleneck if you need to kind of have frequent loops of doing something in the native representation, export to EMF, do some sort of analysis or some sort of code generation. Because usually these exporters are non-incremental, right? So either find a good way to support an incremental exporter, or just provide a different support, so more native support for non-EMF models. And then in terms of what I consider as killer features that could really help convince more people to actually get into the trouble of learning and engaging with these languages, incrementality, because this is very, very difficult to get for a developer to get from scratch using an imperative language. That's clear. Performance. We use high-level languages, which means that they will have much more space for automated analysis and optimization. And what we get in practice is that these languages are usually 10 times slower than Java, if you don't consider incrementality. So again, I think there's a lot of space for improvement here. And of course, heterogeneity. So this is a major problem, having all these different tools, all these peer-to-peer connections, being able to bring together models from different tools in using these languages is very important.
Sorry.
Yes.
So when you talk about killer features,
yeah.
So who is the audience here? Because I think that's the only thing I kind of lost.
Yeah. So the question is, people are already writing these transformations and code generators and so on and so forth in whatever tools are provided by whatever the scripting languages or template languages are provided by their tool, or they choose to kind of export to XML and then write a generator using something like Velocity or I don't know, whatever template engine. Mm-hmm. So the question is, how do we convince them to move over to this set of technologies, to the languages that are built specifically for this purpose?
So if you think about those three categories of users that you mentioned in the beginning of your talk, then now we are talking about the latter two.
Yes,
so
more
individuals who are interested in these kind of technologies and maybe build smaller scale things, and large organizations who are already invested.
Exactly. Because for the second category, it's very easy to hack together a solution in, say, XML and Velocity, or one of the web-based template engines these days. And the latter, the big organizations that already have these big transformations, etc., they need to see any significant potential for improvement in terms of performance, in terms of efficiency, in order to even consider rewriting transformations that are already thousands of lines of code long. And I think that without delivering some of these features, the languages we are developing in this ecosystem are just, we're happy with them, we like to use them, but they're very hard to justify to others. Okay, so some take-home messages. Over the years, a few years ago, I was a bit pessimistic about the actual use of model-based engineering in industry. I started to get the feeling that this is maybe something that academics mostly do, but as over the years, as I have been engaging with more and more companies, I am surprised at how much model-based engineering and things like code generation and model analysis and so on and so forth, and using custom tools, right? So custom transformations, custom generators, is being used out there. I think we have a branding problem, because many people that actually engage in such activities would not recognize the term model-based engineering. You can just say, extract some information and then I produce some code. In the best case, I'm doing code generation. So model-based engineering sounds a bit pretentious and inflated. Domain-specific languages, another lesson learned is that domain-specific languages are not for everyone. And I think that if, from our side, as we are interested in building long-term relationships with partners in industry, we actually make it clear that what you're signing up to is maintenance and training and so on and so forth. We don't want them to get in the situation where they develop something and then they only figure out that, oops, maybe that was the wrong thing to do. Papyrus seems to be getting a lot of attention. As I said, it used to be the case a few years ago that we would go around like insurance salesmen and try to sell model-based engineering to unsuspected customers. Now we're getting a lot of input from industry requests to go and talk to them. They've seen Papyrus, they've started hearing about model-based engineering again, and they want to figure out what it is, if it is for them, etc., which can only be a good thing. Of course, Papyrus, as I said, needs quite a bit of polishing to get up to scratch with commercial UML modeling tools in terms of usability. But of course, this is not going to happen by itself. If we all kind of stand back and wait for Papyrus to get better, it will probably never get better. So I think that's a community effort. That there's a community effort to be put in this one. I talked a lot about frameworks and the fact that frameworks are useful, but in their own right, they're not sufficient. Applications, end-to-end applications, starting with a description of a domain and ending with useful code generators and model analyzers and so on and so forth. It is important to demonstrate the whole tool chain. This is not something that we should leave up to the users to figure out. Model management languages need to provide these killer features, at least some of these killer features, otherwise they're just lost in the crowd, right? And they're not very popular already, so we cannot leverage an existing community of developers, right? And they will remain in relative obscurity. And my last point is that, and this is actually one of the things I have discovered more recently, or at least I have realized the extent of this more recently, is that there are so many tools out there that are actually very good at doing their own bit of the engineering process. They will not be rewritten in any EMF compatible technology anytime soon. Exporting models is not an option when you have to work with big systems. So heterogeneity is a very important concern that we need to embrace as language engineers in this community. And I think that's pretty much everything. Thank you very much for your patience, and I have to apologize again for certain omissions on my slides. They were completely unintentional. Thank you.
Questions?
Thank you, Dimitris, for this wonderful presentation. And I now face to the audience. If you have any questions, I think this is the right moment to ask. So, Zoe, as the newest PhD guy around.
Well, you have talked about heterogeneity, DSLs are scary, and similar things. We had some small experiments in this area, and I see a very big contradiction between requirements here. We can go for a high-level specification language, for example, the drivers in Epsilon or something like that. Either these drivers will be extremely hard to write, or they will miss some features and the end users will want to circumvent the drivers.
Yeah.
We can have do a domain-specific adaptation for each modeling tool. So, for example, for EMF we have names. For Excel we have to index by column and similar things. But then we have to maintain a lot of languages for this purpose, or at least language adaptations.
Yes.
We can go for a language API, but then we will have some limitation. For example, in the case of again EMF, we have to manage the EMF type system and the Java type system together. So I see here a lot of and somehow this will be visible for the end users as well. So I don't know, what do you suggest, or do you have any suggestion for these problems?
So I think that the more code we write, so the more of this hard work of interfacing, say with Excel or Simulink or etc., we do, the less work this means for the end users, and this is important in terms of adoption. I agree that front-ending an existing tool, so adding a layer on top of an existing tool, is unlikely to be as efficient as, say, it's unlikely that you will ever be able to query MATLAB as efficiently using, say, Epsilon and the Simulink driver as you would be through MScript. That's clear. But on the other hand, such in the interoperability layers, such layers don't have to be naive either. So, for example, say, for this particular example, we have some of the drivers we have in Epsilon actually override OCL's select statement, which means that instead of achieving select through naive iteration, they actually delegate to the search facilities of the underlying tool. So their performance in terms of querying is much closer. You'll still be, maybe 100% slower, especially if you think about interpreted languages, etc. But first of all, it just makes certain tasks that were very, very difficult for end users. Like, for example, I have this random UML tool and Simulink. How do they even talk to each other? They don't talk to each other. So, and then suddenly you give them something that can straight point to the one end and to the other end and say, for all activities, make sure they have block with the same thing.
So basically, you say we should limit the complexity for the end users to a reasonable level and provide a killer feature for them to.
I think this is in our experience, this is a killer feature. So because for instance, Epsilon, it's not lightning speed fast by any measurement. So one of the unique selling features that people get convinced about is the fact that they can work with all these different types of models in what appears to be an acceptably fast way, right? But also using very readable specifications, abstracting our way of all these technical things that no one wants to know.
Okay, thank you. I have a question related to this, because to me it sounds very, let's say, appealing on the one hand, but also a bit suspicious, because I suppose you are aware of the OSLC initiative. And OSLC, I think, was primarily invented to address this heterogeneity, right? To facilitate. They didn't even dare to call it model integration, but data integration between various kinds of tools. And it didn't really take off, especially in this industry. So some companies, some tool vendors adapted it, but in a very limited way, and then it somehow died off. But yet, I think what you are proposing is something similar. Just the key difference is that it's not the tool vendor who is supposed to implement the open interface, but some third party who would be you, I guess, in such an industrial academic context. So is this something which actually is viable and scales to complex projects? Because that's the doubt in my head, that if the tool vendors were unwilling to invest into this, is it because they didn't see?
Is it because of technical reasons?
I don't know. It's a very open question. Probably not.
Yeah. So if there's an interest in that, if there's a genuine interest in achieving that, and it's not a very difficult task, I have to say, because most of these, most tools, in my experience, provide some sort of reflective API. So translating things like "give me all instances of X" is usually just one command in the tool, or "give me property Y of object X," just one command in the tool. So it's pretty easy to integrate with.
If you have such an API to start with, but in some commercial tools or many commercial tools, you don't really have that. So
the tools we've worked with so far, including even MetaID, for instance, we haven't tried hundreds of tools, but in the 3-4 tools we have tried, there is an API, and you can get at least the semantic model. Maybe not diagrams, but at least you can navigate the semantic model. I suppose that you have experience with tools where this is not possible.
Yeah, so we've looked into integrating with PLM and requirements, and that there the landscape is rather mixed, because either on the one hand there is a standard for information exchange, it's REC-IF, but there is a lot more information typically inside the tool, and it's a very open question how to get that information out. And another major issue is the lack of incrementality, that you don't really have any ways of tracking changes.
Right.
So these are typically the really difficult problems, because you can really bump into such an issue that you can't really circumvent on your own, because the tool is just closed and walled off.
Yes, that is something we haven't come across, at least not to an extent where it could be a showstopper.
Okay.
So, Albert, how long is your question? Is it a short one? Then you
It's
can.
a short one.
Good, can make
Then
the
ask
answer
it.
long.
Okay.
No, don't do this.
Dimitri will have to answer it in short.
Right.
So my question would be, and we can continue maybe after the presentation, is that you said that you need to sell your tool, you need some kind of reference examples or end-to-end solutions. So, in your opinion, for a model management language, what would be an example or an end-to-end solution that would make an industry partner consider your tool for a completely different problem?
So through these, these end-to-end examples, I would not be targeted at decision makers. So I would not use them kind of sell your tool. You would use it's examples that developers who are interested, just start looking at your tool, would be able to pick up and collect all the pieces and say, oh, here's how I go from abstract models to a graphical syntax to code, and how I deploy, and then I have all the pieces in my head, and I know that if I am to embark on this process of developing something similar for my company, which might be completely different in terms of the actual language, at least I have all the building blocks. So there's no place where I will just not know what to do.
So like a very thorough tutorial that guides you through the entire process of a user story.
Yes, yes. Because this is usually the feedback we most usually get. And then we have to say, oh, you look at this page for a little bit of XText, and then for a little bit of EDL, and then look at this tutorial from Lars Vogel on exporting plugins, etc. Not very nice. I mean, it makes sense to us, but it doesn't make sense.
So I think we can continue with the questions offline. Thanks for your talk, Dimitris. It was a real pleasure having you here.
Thank you very much for inviting me.